What's up, dangerous people? What's up, danger stuff?
Welcome to the first episode of Danger Doc.
Well, to be honest, it's not really the first one, is it?
Yeah, that's true. Usually we do video in Italian, but because this project took so much effort to produce, we decided to share our work with the broader audience. So, forgive us if our English isn't perfect, we are currently trying to improve. Per tutti i fan italiani là fuori, non vi preoccupate che a breve uscirà anche il video italiano non appena sarà finito il doppiaggio.
Now, a second reason why we decided to share this video with a bigger audience is because we thought it was a nice idea to donate all the revenue generated from this video to a charity organization. We really like what Blizzard or the Overwatch team did with the Pink Mercy charity event, and we would like to do something as well, right?
Yeah, that's right.
Blizzard donated to a breast cancer research organization, which I think is very nice, and it's very important to support research. But it's also important to remember that cancer is a battle fought on many fronts. A lot of people are not only struggling with this disease physically, but also mentally and economically. Fortunately, there are some organizations that help cover treatment costs or provide psychological help. In order to provide these services for free, they often rely on donation. What we from Danger Doc thought it would be nice was to donate the revenue from this video to one of these local charity organizations. More about that you'll find it in the description. I'll keep you updated down there.
Now, let's jump into today's project. So, about 2 years ago, me and my friends started playing Overwatch, the new games released from Blizzard. The game isn't very innovative in terms of gameplay, but it has some very particular selling points. The heroes. Every character in this game has a unique playstyle, different abilities, and usually a vague and intriguing background story.
Now, I, being a sucker for the concept of space and time manipulation in video games, immediately fell in love with her. Now, of course, I'm talking about Tracer, the OG hero, the one the devs created first and the one upon which the whole game balance is based. So pure, so perfect, so...
Wait. You know they nerfed her, right?
They did what?
They nerfed her.
Sorry guys, gotta check something.
No, please stop. Please!
Everyone, Jeff from the Overwatch team. Here's another developer update.
This one's gonna be awesome.
I swear. Now that we officially killed every chance we had to work for Blizzard, let's get right into the project.
The first step was to do some research, choose a design and all the components which would better meet the needs for this project. My goal was to build an aesthetically and functionally accurate replica, so I tried to follow a list of requirements I created analyzing some gameplay footage. After brainstorming the various possible sub-assemblies, I decided whether or not said requirements were possible or worth fulfilling. Before we start building, let me explain you quickly how this gun is going to work. This way it will be easier for you to follow the next steps. The following animation is divided in two parts, one mechanical and the other one about the electronics. In this one we can see the various electronic components divided by groups. We have a battery, 3 switches, 1 integrated circuit and 3 electrical loads. The EC used for this project is an H-Bridge L29 3D. In order to better understand the function of this component, I decided to display it in the animation using a symbol that represents his 3 conductive states, which are the default non-conductive state, the conductive state and the conductive state with inverted polarity. Now, when the user presses this push button switch displayed in the bottom left corner, two things happen. The motor responsible for the charging of the BBs is being powered. Simultaneously, the EC switches from a non-conductive state to a conductive state, which allows the battery to power the second motor that controls the side drums. When the push button is released, both motors stop spinning and the H-bridge goes back to his non-conductive state. From a mechanical perspective, we can see that being translated into a clockwise rotation of the side drums and the activation of the high cap mechanism. The function of the high cap mechanism is to draw BBs from a reservoir and to cue them into a rail, which then guides them to the hop-up chamber. Notice that because the rail is now at full capacity, the feeding wheel has stopped spinning. However, the rest of the mechanism is still in motion. That's because under the feeding gear there's a spiral spring. The spiral spring normally functions as a transmission component between the gears and the feeding wheel, but when this is not able to spin, the spring starts winding. Once the spring is fully winded and its internal clutch starts slipping, the user can pull the trigger. This will actuate a limit switch closing the circuit that connects the battery to the Airsoft mechanism. Inside the Airsoft mechanism, a geared motor charges the spring-loaded piston, which generates the pressure necessary to shoot the BBs. Meanwhile, a small plastic nozzle in the front is being moved back and forth, allowing the BBs to enter the hop-up chamber. The BBs are pushed toward the chamber and replaced by new ones thanks to the feeding wheel, which is now forced to spin by the unwinding spiral spring I talked about earlier. The last thing left to talk about is the intermittent counterclockwise rotation of the side drums during the shooting. I wanted to avoid adding more complicated components, so I found that the easiest way to generate such a rotation was to take advantage of an already included component that performed such a movement, the anti-reversal latch, which in this gearbox conveniently has a part that sticks out of the chassis. This lever is usually used for maintenance purposes, but in our case is going to be used to actuate a second limit switch. When this one is pressed, the second circuit closes, changing the H-bridge from his non-conductive state to his conductive state with inverted polarity. This state of conductivity is only maintained when the limit switch is pressed, so because the lever is constantly moving while shooting, the signal that the motor receives is not constant but rather pulsating. This way, the side drums are able to perform the intermittent rotation. So that's basically how the gun works. Now I'm going to show you how to build it. First of all, let's go through all the important components I used to make this project. Probably the most important component of all is this gearbox model Well R2 VZ61. This gearbox is a cheap knockoff of the Tokyo Marui VZ61. It ain't very powerful, but it has a good rate of fire, and it cost just 25 euros. I also bought a high cap magazine of the same model. My idea was to disassemble the magazine, take the components and re-engineer it into the pulse pistol mag shell, turning the original manual charging into a motorized one. To power all the electronic components, I used the 7.2 volt Golden Bow LiPo battery. Unfortunately, this battery turned out being a little bit too weak and ended up running out of juice very quickly. To automate the high cap and make the side drum spin, I used two geared motors. They have a speed of 300 rpm and a minimum torque of 2 Nm, which is enough to make the spiral spring wind completely. To make the transmissions between the motors and the various mechanical components, I used some 0.5 metric model gears. I also used some brass bevel gears in order to transmit the higher torque. Last but not least, I used some blue SMD LEDs and resistors to create the illuminated details. Once I had all the components, it was time to start using the CAD program. I used Autodesk Inventor to make the 3D models. The models were then converted to G-code and printed with our 3D printer using PLA filament for the structure and PVA for the support. The printed parts were later cleaned from the support material and reworked by adjusting some details, sanding down some printing imperfection and adding brass inserts to ensure the resistance of the threadings. Despite the rework, the fused filament fabrication often leaves a pretty rough surface, which gets even nastier when someone tries to paint over it. To solve this problem, I usually fill the gaps and the imperfections with a thin coat of fiberglass putty. Once the coating has dried, the surface can be smoothed using some fine sandpaper and later painted using any kind of spray paint. I decided to go with a personalized adaptation of the sporty skin. I find this one amongst all skins is the coolest because it's simple, it doesn't drift too far from the original design, but still leaves room for customizations. I didn't want the gun to be too monochrome, so I decided to spice things up by wrapping the magazine casing with some carbon fiber themed film. In order to achieve a good adhesion and avoid losing details, I used this homemade dimple perforated bench. Once the casing was complete, it was time to add all the internal components, so I started disassembling the high cap mag eyeball. In this footage you can see the spiral spring I wasn't able to show in the animation. As you can see, when the feeding wheel is being held and the rear crank is turned, the spring winds itself. Because of this, the wheel is later able to rotate and move the BBs without an external input. As I said, my idea was to automate the spring charging. To do so, I decided to replace the crank with this geared motor. However, because the original transmissions were not designed to be motor operated, I had to replace all the gears as well. A common problem that occurs when designing a mechanism that has to move spherical objects is that these often get stuck whenever there's a choke or some moving parts. The first prototype of the magazine was terribly compromised by this problem, so I had to design this flexible ABS component that alters his shape, allowing the BBs to rearrange, which prevents them from getting stuck. To be 100% sure that the high cap won't jam, I paired the feeding wheel with this special gear, which reshuffles the BBs every time the feeding wheel is spun. I then proceeded to assemble the side drums transmission. I used some brass tubes to create the shafts and a small ball bearing to reduce the friction and the radial clearance. Now, before I proceed to explain how the wirings and all the electronic connections were made, there's a last mechanical assembly that we need to build, the hop-up chamber. Because this pistol is so unique in terms of structure, it was hard to find a hop-up chamber that met the needs, so I decided to build my own. The first step was to make the mold for the bucking. To do it, I simply fabricated these two metal components using a lead. Unfortunately, I wasn't able to find a small and cheap amount of bi-component rubber, so I had to find a different solution. I don't know about your childhood, guys, but mine was full of third-degree burns and tears. The reason behind this was this fucking toy called Thing Maker. This product was basically a small furnace that used an 80-watt light bulb to heat up an aluminium mold filled with a polymerizing substance. This toy was discontinued in Switzerland a long time ago, probably due to the shit ton of lawsuits against the manufacturer. But fortunately, my colleague managed to find in a thrift shop a 13-year-old specimen of it. Luckily, the chemical substances did not expire and we were able to use them to make the bucking. I then machined an aluminum round bar to create the hop-up chamber. This part had to be made out of metal because the printed version I previously tried to use was wearing out too quickly and sometimes even fused with the nozzle because of the friction between the two. I also had to replace the gearbox nozzle because the original one is designed for a specific hop-up chamber, so I printed a longer one that I could use in my assembly. Once I had all the components, it was time to put them together. I inserted the barrel, the bucking and the chamber in their 3D printed holder and locked them together using a headless screw. Now that the mechanical components are done, Let's move to the electronics. The first task to take care of was finding an easy and convenient way to connect all the components to the power supply. Normally this should be a simple thing to do, but because this battery has flat terminals instead of a standard cable, it was quite a headache. I decided to build two aluminum tracks to conduct the current to both the lower and the upper area of the grip. In order to connect these two aluminum strips to the battery, I used two threaded spring plungers. Using this method, I was able to easily adjust the distance and the preload of the connection by simply screwing or unscrewing the components. The next thing on the list was to wire the EC and the geared motor. Remember to check the wiring diagram shown in the animation if you have any doubts. As for the EC pinout, I suggest you to find a specific datasheet when you buy the component.
I'm gonna throw my memories away. Now I feel I'm done, and I am cursed by every day till my time is gone. I've never felt this way before, and now I know this all for sure. I won't forget your last betray. I'll never forget this day. I'll never forget this day.
Once the important parts were done, I focused on the aesthetic details. I created some ladder rails for the two sides of the chamber, the rear part of the gun and the side drums, of course.
I'll never forget this day.
I then tried to fulfill the last remaining requirement for this project, the fluorescent projectiles. If you're an airsoft connoisseur, you probably know this. They are called tracer BBs. What's special about them is that they can glow in the dark, but to do it they have to go through a device called a tracer unit. Now, I didn't want to use a tracer unit on my gun because it was going to ruin the original design. So my idea was to find a small source of light that I could put inside the magazine to charge these fluorescent BBs. I tried different colors and different types of LEDs. The best result was achieved with an ultraviolet superflux LED. Unfortunately, this required so much power to operate that it was literally causing the gearbox to stall. So I had to replace it with 4 smaller SMD blue-violet LEDs. Once that was done, I assembled the last components, did the final connection and secured everything with some screws. And this, guys, is the final product. I'm really proud of the results, I really like the design, the personal touches, and I hope you like it as well. I'll leave it on the screen for a few more seconds so you can enjoy it, and then we'll move to the final test.
here. Should be okay. Ok, tradizione che su Danger Dog quando si costruiscono le armi le si testano su soggetti umani. Oh, but why? No. You asshole, you done?
Yep.
Ma pezzo di ano!
So that was all for today's video. We hope you liked the project. If you do so, please leave a like, subscribe and maybe also a comment. If you don't like it, please share it with your friends so you can help us raise the money for the organization we talked about in the beginning.
As for the 3D models and the technical documents, please leave me some time to check and correct them. However, remember that if I don't see a genuine interest from the community, I reserve myself the right to not share them publicly. Now, since this is the first video we do for the worldwide community, please consider leaving us feedback in the comments. So, did you like the video? Was the project good? Was our English bearable? I know I have a little bit of a Bulgarian, German, Italian accent, so I hope it's bearable. We literally butchered your language. Sorry for that.
We're sorry. Genuinely sorry.
Whatever.
Whatever. See ya guys next time.